Okay, we're going to take a look at section 4.4 today, and so I just want to do a little bit of a flashback. Remember that when we multiply powers with the same base, we add the exponents. We talked about that at the very beginning of this unit too. So I've got an example written here. 5 squared times 5 cubed, bases are the same. So we'd add the exponents, we end up with 5 to the power 5. So that premise is important for this as we extend our knowledge into this unit, because we're going to look at powers now with fractional exponents. Okay, so here's an example right here. So if we had 5 to the exponent 1/2 times 5 to the exponent 1/2, we would add these two exponents. 1/2 plus 1/2 is 1, so we get 5. Okay, so what this is trying to show you is that when we take a power and we raise it to a fractional exponent, okay, we're going to get a square root. Okay, so here we go. If we had 5 to the exponent 1/3 times 5 to the exponent 1/3 times 5 to the exponent 1/3, if we added 1/3 plus 1/3 plus 1/3, we'd get 1. Okay, and we know that the cube root of 5 times the cube root of 5 times the cube root of 5 really means the cube root of 125, which is 5. So really what we're saying here is 5 to the exponent 1/3 is really finding the cube root of 5. So I know that's all new, but what we're really meaning to say here is that when we raise a number to the exponent 1/2, it's the same as taking its square root. Okay, so what we've discovered is that this denominator, okay, is the root. And so when we raise a number to the exponent 1/3, it's the same as finding its cube root. Okay, so that's going to be important. And now what I want you to know is when we're looking at a fractional exponent, the numerator stands for what we're going to raise to the exponent, and the denominator is the root. And that's not making sense right now, okay, but it will as we go through some examples. So top number exponent, bottom number root. Okay, so here we go. We're just going to do slow today. We're just going to do this next page. That's it. Okay, so I always do this. I go exponent, root. So I have 27. I'm going to raise it to the exponent 1, and I'm going to find the cube root of it. So we write it like this, cube root of 27. Okay, and it turns out to be really simple. It just looks really weird because you've never seen it before. So just move past that. Okay, go into this with a good attitude. The cube root of 27 is 3. Done. Final answer. Okay, exponent, root. And the reason why these are so nice is because when we have an exponent of 1, that really doesn't change an answer. Okay, so these ones that have a numerator of 1, we only have to worry about the root. So now we're going to find the square root of 49. What's the square root of 49? 7. Okay, now here we've got an exponent of 1, root of 3. Can we find the cube root of a negative number? And indeed, if you remember, we can. As long as the index is negative or is odd, we can answer this. We're going to get a negative 4. Okay, now we have this in brackets. We're going to keep it in brackets. Okay, if I asked you to find me the square root of 4/9, if you remember from earlier, we find the square root of 4, which is 2, and the square root of 9, which is 3, and that's our answer. Okay, so it looked really weird and thought it was going to be hard, but it turns out when you just know the rules, things turn out to be pretty easy. Okay, now we're going to find 1,000 raised to the exponent 1/3. Exponent, root. So we're simply going to find the cube root of 1,000, and the cube root of 1,000 is 10. Done. All right, now here, a little bit harder. We're going to find the square root of 25 1/100ths. I find it easier to turn that into a fraction when I read it. Okay, what's the square root of 25? 5. What's the square root of 100? 10. What would I like to see done here? Turned into 1/2. I'd like you to reduce the fraction here. Okay, quick question. Can we find the cube root of a negative number? Answer is yes. Cube root of -8, our answer is going to be -2. Now a little tougher, and you're allowed to use your calculator if you want to. Okay, this is all about feeling comfortable about this. We just started. We need to find the 4th root of 16/81. Okay, and because I'm old, I've got time and experience on my side. Okay, the 4th root of 16 is 2. The 4th root of 81 is 3. More than welcome to use a calculator to help you out with that, okay? Okay. Now we're going to use a number other than 1 in the numerator. Now we're not going to do an assignment like this, but I'm just going to quickly show you a couple, okay? We're going to learn through this example, and then we're going to look back at our examples and establish the rules. I think this is going to make more sense to you. Okay, so let's just do this. Exponent, root. So we're going to always start by finding the root, and then we're going to raise it to an exponent. So what's the cube root of 27? 3. And then we're going to raise that to the exponent 4. So what's 3 times 3 times 3 times 3? 81. Again, feel free to use your calculator. Okay, and up here now, a little bit tougher. Read the exponent. The exponent's not written as a fraction yet. 4/10, which reduces to 2/5. Okay, so now we're going to find the 5th root of -32, and then we're going to square that. Can we find the 5th root of a negative number? Yes, because the index is odd. -2. Then we're going to square that. The answer is 4. Okay, probably the toughest one I'm going to show you today, but you got this. I know you got this. All right, exponent root. So we're going to find the cube root. I didn't write that very well. Of 27/8, and then after that we have an exponent that's not 1, so we're going to square that after. Just like almost like bedmouse. What's the cube root of 27? 3. What's the cube root of 8? 2. And now we're going to square that. 3 squared is 9. 2 squared is 4. All right, I totally get it. This is brand new, so we're going to do this again. Okay, another example tomorrow. Today, I just want you to read it over and take a look, okay? Call me if you have questions.